welcome to the Absolute Recap Biology Edition. I'm your host, Melanie Kingett, and I'll be your guide to scoring a 5. Here at the Absolute Recap, we aim to maximize your understanding and minimize your need for memorization. Each episode will review content, skills, and test-taking tips to help you succeed in May. Your recap starts now. Hi, and welcome to the Absolute Recap Biology Edition. Today's episode will recap energy and graphing. Let's zoom out. One of the most challenging parts of science is interpreting scientific models. These diagrams, charts, simulations, and graphs try to demonstrate something about the natural world. It is our role to extrapolate what we can from these models, apply the information, and make predictions. You will not be required to create a graph on the 2020 exam. However, FRQ1 is interpreting and evaluating experimental results. You will be questioned about an authentic scenario accompanied by a data table and/or a graph. Let's zoom in. Graphs come in many forms, depending upon the type of data being represented. Does your question talk about a range of data points or groups? You need a frequency plot, such as a box and whisker, dot, or histogram. Does your question need to compare two or more qualitative groups? You may also need a frequency plot, or maybe a bar graph. It's common to include error bars, 2 times the standard error of the mean for biology, on these types of graphs. Does your question compare to quantitative variables? Then you need a scatter plot or line graph. If your question investigates part of a whole, you'll use a pie chart or a stacked bar chart. Let's assume you're using the right graph for your data. Congrats! The work is not done yet. Graphing hack, dry mix tails. Dry, the dependent variable, also known as the responding variable, is graphed on the y-axis. Dry. The y-axis is vertical on a graph, just like the tail of the letter y goes up and down. The dependent variable is the output of the experiment, what is being measured by the scientists as a result, and typically entered in a data table. Mix. The manipulated variable, also known as the independent variable, is graphed on the x-axis. Mix. The x-axis is horizontal on a graph. This is the variable the scientists are changing on purpose. All graphs should also have tails. Title. Appropriate and descriptive. Axis label with each variable and units, because numbers without units have no meaning. Intervals. The numbers are equally spaced in value and graphing distance. Legend, also known as a key, and usually color-coded, and scaled to your data with minimum and maximum values. You don't want most of the graph to be empty space. Tails. Altogether, graphs have dry mixed tails. The title of this episode is Energy and Graphing. So let's recap energy first and then put the two together. The first law of thermodynamics states that the energy of the universe is constant. Energy can be transferred and transformed, but it cannot be created or destroyed. This is the primary piece of information behind energy graphing, as most reactions in biology participate in the transfer of energy from one form into another. We maximize our efficiency during energy transfers through sequential biological pathways, where the product of one reaction step is often the reactant for the next. We also use enzymes, biological catalysts that lower the activation energy for a reaction to occur. All molecules have energy stored in chemical bonds, with some having more energy than others. It breaks every chemist's heart when biology teachers say that energy is released when bonds are broken, right? ATP loses a phosphate and becomes ADP, quote-unquote, releasing energy. Breaking bonds requires energy, but the emphasis needs to be on the remaining energy of the products. Are they at a lower or higher energy level than the reactants? Reactions require an input of energy, known as activation energy, to occur. Enzymes reduce how much energy is required for a chemical reaction to continue, and thus make metabolism more efficient. Note that the difference in energy from reactants to products remains the same in a catalyzed versus uncatalyzed reaction. Okay, combining the two, energy and graphing. We are going to analyze 2 graphs to distinguish between energy storing and energy releasing reactions. The y-axis is Gibbs free energy, and the x-axis is time. The line drawn on the graph shows how energy levels change over time during a chemical reaction. Energy levels increase in both graphs at first, with the peak of each curve representing activation energy. This hill will be smaller in catalyzed reactions. Exergonic reactions have energy exiting the system, with reactants at a higher energy level than products. These reactions have a negative delta G, a free energy value, and are spontaneous. Imagine yourself walking along the graphed line. You go up and over the hill, then land in a lower valley. Examples of exergonic reactions include the formation of ADP and the process of cellular respiration. Energy cannot be created or destroyed, just transferred. Cellular respiration transfers energy from glucose into ATP, with many steps in between. Endergonic reactions require additional energy with reactants at a lower energy level than the products. Energy is stored in these products. These reactions have a positive delta G and are not spontaneous. Imagine yourself walking along the graphed line again. You go up and over the hill, coming down only partially before landing on a plateau. Examples of endergonic reactions include the formation of ATP and the process of photosynthesis. Where does this input of energy come from? Well, for ATP, perhaps it's chemiosmosis through ATP synthase. For photosynthesis, thank you for the sunlight. To recap, graphs tell the story of experiments, but it is up to you to interpret them. Don't forget dry mixed tails, and please always include units with your numbers. Endergonic reactions land the products on a plateau, whereas exergonic reactions fall into a valley. Today's question of the day is about energy. What does ADP stand for? For the answer to today's and future questions, please follow us on Instagram at TheApsoluteRecap. That's the APsolute recap. If you are a student with questions or a teacher with suggestions, we'd love to hear from you. If you have a biology topic or another AP subject you would like us to cover on the Absolute Recap, please email us at TheApsoluteRecap@gmail.com. That's the APsolute recap@gmail.com. The Absolute Recap is produced by Brad Kingett with music by Zach Caruso. Please remember to rate, review, and subscribe wherever you get podcasts. Time's up, pencils down. Thank you for listening to the Absolute Recap Biology Edition. AP is a registered trademark of the College Board. Copyright 2020, Absolute Recap, LLC, all rights reserved. Coming up next on the Absolute Recap Biology Edition, signal transduction and the nervous system.